right, here we go. We're on 10-5 tangents. Have you guys ever heard someone say I went off on a tangent? Okay, so once I explain this, you'll kind of understand where I think it comes from. Maybe it doesn't, but it makes sense to me. So tangent is a line in the same plane as the circle that intersects the circle in exactly one point, the point of tangency. So if you look at your picture here, this is a tangent line to this circle because it only intersects it in that one spot. So when someone says I went off on a tangent, it's kind of like, okay, well, I was kind of talking about what you were talking about, but just that little bit. Then I kind of went off on my own. Does that make sense? Makes sense to me. A common tangent is a line, ray, or a segment. It could be any of those. That's tangent to two circles. So a common tangent, when we get to your homework today, you're going to have one that looks like this, something like that. I think it's number 12. Okay. A common tangent here, it's really hard to draw on this thing, but you see how this line touched both circles in just one spot? That would be a common tangent. Okay, and again, when you get to that question in your homework, there's actually two of them there, but draw it better than I did. There's actually two of them. That's not very good. I should have drawn it more like that. Do you guys get what I'm saying? That's a common tangent. It touches each circle in just one spot. Okay? And I'll do that again when you guys get to your homework so you can see what it with a prettier picture. Theorem 1010, in a plane, a line is tangent to a circle if and only if it's perpendicular to a radius drawn to the point of tangency. So here's my tangent line. Everybody good with that? Here's a radius of the circle. Because the radius is touching that tangent line where it intersects the circle, this is a right angle. That's all that says. Okay? 1011, if two segments from the same exterior point, so here's a segment here, and here's a segment here, that's the same exterior point right there. If they're tangent to the circle, this one and that one, then they're the same, congruent, right? That's it. Okay? Determine whether XY, line segment XY, is tangent to the circle. If it's tangent to the circle, what would that mean? Is that theorem 1010 or 1011? Which one do you think we've got here? 1010, right? So if it's tangent to the circle, what do we know about it? It makes a right angle. Very good. So angle Y would have to be a right angle. I don't know if it is or not. I'm saying if this is tangent, it better be a right angle. How am I going to check to see if it is? How do we check to see if a triangle is right, is what the picture shows. Pythagorean theorem, right? If it fits the Pythagorean theorem, it's a right triangle. If it doesn't, it's not. Make sense? But you were thinking. So that's good. Okay? So leg squared plus leg squared equals, what's my hypotenuse on this one? 8. The hypotenuse of the triangle would be 8, right? So 5 squared plus 8 squared is going to give us the whole thing. So you got your 25, you got the 64. So 89 does not equal 64. So is this tangent, yes or no? Nope. If those two were equal, it would be yes. Yeah. Okay, are you sure? Okay. There's a right triangle, we have the two legs, we have the hypotenuse. If it fits the Pythagorean theorem, it's true. If it doesn't, it's not. This whole side here was 8. So 8 squared is 64. So I was trying to see if this squared plus this squared equals this squared, and it does not. Is that okay? Okay. All right, this time it says find x. Assume that segments that appear to be tangent are tangent. Round to the nearest tenth if necessary. What that means is on that last question, they were asking if it was tangent, so we had to see if it fit the Pythagorean theorem or made a right angle. On this one, they're saying, hey, if it looks tangent, just go ahead and say it is. So what they mean is, looks like QP, in my opinion, looks tangent to circle N, so I'm going to assume it is. So because QP is tangent to circle N, that means the angle P must be a right angle. I'm not guessing. They told me to just go ahead and assume that information is correct. Okay? So we're going to say 10 squared plus 24 squared equals x squared. Okay? What do you get when you take 10 squared plus 24 squared? 676 when you're done with it, right? and then square root both sides, and x is 26 exactly. We're not rounding. Did I lose anybody? Super easy? Okay. Anyone still need that page? All right. Same concept here. It looks tangent, therefore angle B must be a right angle, right? So leg squared, that's my x squared, plus leg squared, that's my 12 squared. What's my hypotenuse? I'm going to say x plus 6 because most people prefer it that way, but you're not wrong, okay? X plus 6 quantity squared. So pretty okay with what I just did, okay? So x squared we just write again. 12 squared is obviously 144, okay? This is not x squared plus 36. That is not a shortcut that exists. That's not true. If you ever want me to show you why, I can, but that's not how you do it. Do you guys, yeah, we're going to have to FOIL that. Do you guys understand why you can't just say that's x squared plus 36, not just because I said? Let's do this for 2 seconds. Pause for just a second, okay? Let's do 1 plus 2 squared, okay? What's 1 plus 2? 3 squared, 9, right? 1 plus 2 squared is 9. We just did that math on our own, right? If you accidentally think this is true, that this is x squared plus 36, that's like a shortcut that exists, you would say 1 squared plus 2 squared, wouldn't you? Well, what's 1 squared? 1, 2 squared, 4. 4 plus 1 is 5. It's not a shortcut that exists. So that's why we have to do what we're going to do here. X plus 6, x plus 6. Everybody in here can FOIL. First, outer, inner, last. I'll help you remember, but you can. Super easy, right? So I still have this x squared plus 144. So we have first times first. What's x times x? Nope. X to the second. Good. Outer. Yeah, that first step is always multiplication. So x times a positive 6 is a positive 6x, right? Inner. X and 6 times each other is 6x again. Last two positives make a positive, 36. Is that okay? All right. Combine like terms, I've got x squared plus 144 equals x squared plus 12x plus 36. I'm going to cancel the x squareds out. If I subtract it, it cancels out on both sides. So I'm left with 144 equals 12x plus 36. What do I do now? Subtract 36 and you get 108 equals 12x and x equals 9. Is that okay? Pretty easy. All right. Anyone still need that page? Okay. Does this look like theorem 1010 or 1011 to you? Probably 1011, right? So these are the, they're both tangent to the circle from the same exterior point, therefore they are congruent or equal, right? So 5x minus 9 is equal to x plus 7. X is 4. Did I lose anybody? Okay, that's it.